Hello there, and in this video we're going to take a look at how to conduct hypothesis tests by using confidence intervals for the population mean. And this video is focusing on the particular case that the standard deviation of the population is going to be known to us. So let us consider a variable x that represents the amount of time that people spend taking on the test, measured in minutes. And let us assume, for the sake of this example, that x is normally distributed with some mean mu that we seek to estimate, and let us assume that the standard deviation of this population is 5.2 minutes. And let us assume also that somebody claims to you that the mean is equal to 94. They could be right, they could be wrong, they could be pretty close. Let us perform a hypothesis test with an 8% level of statistical significance against this claim that mu is equal to 94. So let's begin. So we're giving that the null hypothesis, H0, is that the mu, or the mean of this population, is going to be equal to 94 minutes. So we're going to use the alternative hypothesis for the sake of this example, that mu does not equal to 94 minutes. Because it could be less, it could be more. Let us assume we don't have any prior knowledge of this problem. It's also given to us that we must operate under a statistical level of 8%. So that implies that our level of confidence is going to be 0.92. Alright, so we know that sigma is known to us, namely it's 5.2 minutes. So let's see what we can do. So we know for a corresponding confidence interval, and let's draw a very familiar picture here. So we're familiar that the confidence region is going to be symmetrically distributed within this region, and this area by assumption is 0.92, and half of the tails, since alpha is 0.8, alpha over 2 is going to be 0.04. So that means 0.04 is here and 0.04 is over here. So since the sigma is known, we're going to assume that this is going to be normally distributed. So that means this curve drawn is going to be the normal distribution. So that means there exist two numbers, z alpha over 2 and minus z alpha over 2, that corresponds to this level of confidence, 92%. Alright, so we can sort of start to find what these numbers are going to be equal to. So that means the integral from minus z alpha over 2 to z alpha over 2 of the standard normal distribution with respect to z must be equal to 0.92. So I leave it to the person watching this video that this number z alpha over 2 is going to be equal to about 1.751. And this is what we call the critical value for our confidence interval. Alright, so with that being said, we can now calculate the marginal error for our confidence interval. So E, recall, is the marginal error, is going to be equal to the critical value, z alpha over 2, multiplied by sigma divided by the square root of the sample size. So let us assume we plan to gather a sample of, let's assume we're going to get, say, 43 people. So if that is true, then that means the marginal error for my confidence interval is going to be equal to 1.751 times the standard deviation of the population. That was assumed to be 5.2 divided by the square root of 43. And once you work out that calculation, that's going to be approximately equal to 1.3885. So that's the marginal error for my confidence interval. So from here, I'm going to gather my sample. And my sample is going to come from that population. And keep in mind, this sample should be simple and random, and all the values should be independent as much as we can guarantee. And let us assume that the sample mean of that sample is going to be equal to 112. Assume. So if that is true, then that means what? So that means my confidence interval for my population mean mu under a 92% level of confidence is going to be equal to, from the definition, is going to be equal to x bar minus the marginal error comma, x bar plus the marginal error. And that's going to be equal to 112 minus 1.751, comma, 112 plus 1.751, approximately. So that means my confidence interval, my 92% confidence interval, is going to be equal to approximately 110.61, comma, 113.39, and these boundaries are measured in minutes. So this is my 92% confidence interval. Therefore, based on my study, I am 92% confident that the population mean mu lies somewhere in between 110.6 and 113.39 minutes. So that's pretty much the conclusion. It doesn't mean that mu is actually in here. It could be outside. We don't know because this is based on our sample, and that's pretty much a very important thing to keep in mind here. But based on the sample, what can we conclude? Well, since the claim H0 is that, let's see, what was the claim? That mu is equal to 94. So this value is not inside of our confidence interval. So I have, at least based on my sample, I'm 92% confident that this null hypothesis is actually wrong. I'm confident that it is, 92% at least. So that means what? That means since mu0 is not within my confidence interval, I will reject the null hypothesis that mu is equal to 94, because I'm 92% confident that mu is between these two numbers, and 94 is in between 110 and 113. So I am at least 92% confident that they are wrong. So I'm going to reject the null hypothesis, and this is based on my sample S. And that's pretty much how you go about conducting a hypothesis test for the population mean with confidence intervals. So pretty much the two basic things that you are going to have in front of you is that if mu0, so pretty much the null hypothesis H0 is that mu is equal to something, and this applies for the alternative that mu does not equal to that number. So if mu0 does not belong to the confidence interval, then you're going to reject the null hypothesis. And if mu0 does belong to the confidence interval, that means you don't have evidence against what they say because your sample actually agrees with what they say. So that means we're going to fail to reject the null hypothesis. And keep in mind, rejection does not mean that you actually think they're wrong, and failing to reject does not necessarily mean that you believe that they are correct. It's pretty much just what we can say based on this sample and this level of confidence. And that's pretty much how you go about conducting a hypothesis test if the sigma standard deviation is actually known.